Okay, so we are now looking at two variables, inequalities in two variables. They are just going to be linear ones, so we are going to have to plot some lines and then shade in one or other side of the line, depending on whether we're bigger or smaller. So that's the game for this. But the idea of doing this, well, there are several points. One is it leads very nicely into linear programming if you do any of that later. So you'll often have business decisions that can be represented using kind of a linear optimization problem. Like you need to maximize the profit that you can get given a certain number of constraints, for example. So it leads into that you could do in another course, and then you can look at the simplex method for solving that, which is a very powerful and ubiquitous kind of process. But anyway, this is just to set the scene for that. So linear inequalities in two variables. So we have a few possibilities. Obviously, we could have, there's going to be an inequality somewhere, and I want it to be linear, and I want two variables, so x and y. Any inequality of the form ax plus by is less than or equal to c, or of course I can have bigger than or whatever I like, is going to be one of the things that we're looking at, an inequality in two variables. And it can be sketched. And here's how I propose that you do this in the quickest way. Either there won't be a y in it at all, because the b will be 0, and so there'll just be an x. So first of all, if there's no y in it, because b is 0, then you just get something of the form so it's going to be of the form x is less than or equal to c over a. But remember, if a is negative, you might have to swap the sign. So you might get x is bigger than or equal to c over a. And of course, it will depend on what the inequality you start with is. But however you do that, however you work that out, you're going to get just something straightforward to pick. So let me imagine that this is c over a. And if I want x less than or equal to c over a, I just want this part of the picture. And we'll sort of build up bigger sort of intersections to show the sort of solution space here. But that's one of the most simple. Otherwise, you can rearrange this to get something of the form y equals mx plus c. So otherwise there is a y in it. So let me just make sure that you know what this area is. So be very clear and just say that this is x less than or equal to c over a. So otherwise there is a y, and we can rearrange for it. And we're going to rearrange it in the form that we most prefer when sketching lines, and usually for most people that is mx plus c. So rearrange to get y, and of course, again, it's going to depend on what you start with, and if you're divided by a negative number, you need to swap the sign over, but to get y less than or equal to mx plus c. And then the thing to do is, this is if you had a line, draw that first, and then just decide which side of the line you're on. So draw the line y equals mx plus c, and color in the area. So shade the correct side. Okay, and it's quite easy to see what the correct side is going to be. So if you know that y has to be less than or equal to what this line would have given you, then you want all of the points where y is underneath it. So the points where you lie on the line are when these are equal. So if your y coordinate is less than anything that's on the line, then you're going to be under it, and so you're going to satisfy this. So let's just do an example. So e.g., let's say y is less than or equal to 2x plus 3. Okay, so it's got a gradient of 2, and the x-intercept is going to, so the y-intercept is where x is 0, and then we get 3. So we're going to be going up like this. Might be nice to have a different color. Let's do it with this color. So this is going to be, if that's 3, then what would the y-intercept be? It would be minus 3 over 2, the x-intercept be minus 3 over 2. So I can draw that on if I like, and then I want all of the y's that are less than this. So all of the y's with a smaller y coordinate. So it's just going to be everything under this line. Right, so that's the basic picture. So this is now, this green bit is now y less than or equal to 2x plus 3. So hopefully that's kind of clear, but we'll do some more examples if it is not. Okay, so we'll do an example. So we're going to find all, I'll explain what this means. Find all the points x, y in, so this is the integers, across the integers. So these are just going to be pairs of coordinates that have integer values. Find all the points, the integral points, that lie in the region of the plane bounded by the following inequalities. So we will take, let's have x bigger than or equal to 0. So it should be a nice easy one. Let's have x plus y. That has to be bigger than 1. I'm going to have y over 2 plus x over 3 is less than or equal to 1. And I'm going to have let's just say I'll take x less than or equal to 1. Okay, so those are my inequalities, and basically what I'm doing is solving them simultaneously. Now, normally you have, if you've got like simultaneous equations, like that could be represented like this with lines, then you'd have two of them and you'd solve those two together. But here, with inequalities, you can have more than two and it still be a worthwhile thing to do. So let's have some axes and then let's deal with things as we find them. So here are my axes. This is the y-axis. This is the x-axis. So I want x bigger than or equal to 0. So these are all the x coordinates that are bigger than or equal to 0. These are all the coordinates that have value exactly 0. So I can start with this side of things. So this is going to be x bigger than or equal to 0. Pretty straightforward. Now, x plus y bigger than or equal to 1. So I might want to reorganize that first. So this I can turn into y bigger than or equal to 1 minus x if I like. And so that's a y equals mx plus c. Alternatively, you can just see what the x and the y intersects are going to be here, because if I take x is 0, that tells me y is 1. If I take y as 0, that tells me x is 1. So I can do it either from that form or this form, but I'll do it from this form because it's a bit more straightforward. So I get those two intersects. I want to draw the line between them. Let's use this. That's supposed to be there. And then I want to decide whether we're above the line or not. So I want the y coordinate, x plus y, to be bigger than or equal to 1. So I want, when I add them together, I want to get something bigger than 1. So this is where it's equal to 1. If I add them together, I get something bigger than 1. It's going to give me this, this direction. So this is the area x plus y bigger than or equal to 1. Okay, so we've done first two. Again, this is actually in a nice form. We can work out what the x and y intersects are. So put x is 0, then you get that y is 2. So we're running out of different colours of pen at this point, but let's see if we can. So this is going to be 2, the point 2. And then if I put y is 0, I get x is 3. So that's going to be all the way over here. So I can then put a 3 and I can connect them together, and then I can do another shading all the way down here. Okay, so we've still got a kind of an infinite region here. So let's give us one more one more thing here. So this is where x is going to be less than or equal to 1, and I don't. Oh, there's a blue one here. So let's do x is less than or equal to 1, and we're going to be on the left-hand side of this. So we go here. Okay, so we are eventually bounded by this one to the right, this one, we're to the right of this one, to the left of this one, we're under this one, we're above this one. So we've got this shape we're looking at. Okay, and we're going to work out some other intersects. We want to know what this point is. So this is the point where x is 1 and it meets the line given by this. So if x is 1, I get a third. So for this is the line, is the point where x equals 1 meets y over 2 plus x over 3 is less than or equal to 1. So we can put that in there. We get a third. Let's say equals because we want the exact point. So put 1 in there to get a third. Move it over. You get 2/3. Y over 2 is 2/3. So y is 4/3. And x is 1. So this is the point 1, 4/3. Okay. So remember what the question was. The question was find all the points that are integral in this region. So here's one, because this is the point 0, 1. So perhaps I'll... So this is the point 0, 1. This is the point 0, 2. And then I want all the integral points. So I just want to find everything that's between here and inside this region. Here's another point that I can certainly have. That's 1, 0. I can also go up to, so this goes up to 4 over 3. So I can go all the way up to 1, 1, in fact, here. I can't go up to 1, 2 because that would be bigger than this, it would be outside the region. And I can't actually put any more in here. So it's just these 4 points. And you're just going to find them by trial and error, really, after you've got the intersects. So the 4 points are 1, 0, 1, 1, 0, 1, 0, 2. Okay, and that's the sort of basic way that these problems go. But the main point is to be able to sketch the areas between inside the inequalities. One last point, you're not going to have graph paper in the exam, but you should be able to do a sketch just like this one, even if you don't have a ruler. So you can knock something together. You're not going to get points for how neat it is. As long as you can work out where the intercepts are, that's good. Okay, and we will, in the last video, look at complexity, and then we'll be done.